In this video, we're going to do section 3.3.2 on higher order partial derivatives. If f is a function of n variables, then each of its n partial derivatives is also a function of n variables. So it stands to reason that we should be able to take the partial derivatives of each of the partial derivatives. These derivatives of derivatives are called the second order partial derivatives of f, assuming that they exist. If we differentiate yet again, we get the third order partials of f, and so on. In general, everything past the first partials are called the higher order partial derivatives of f. Notation. So if z is a function f of xy, then there are 4 second order partials depending on our order of integration. Number 1. Del squared f del x squared, which is, or means the same as take the derivative, del by del x, of the first partial, del f del x. Another notation for this is f sub xx, which is take the derivative of f sub x with respect to x, which means first differentiate with respect to, not with w, nope, don't know where that came from, with respect to x, then differentiate again with respect to x. Second order partial, del squared f del x del y, which means take the derivative with respect to x of the first partial with respect to y. Other notation, f sub yx, which means take the first partial with respect to y and take its derivative with respect to x. This means we're first taking the derivative with respect to y and then with respect to x. Next case, del squared f del y del x. Take the derivative with respect to y of the first partial with respect to x. Other notation, f sub xy, which is the same thing. The derivative with respect to x is differentiated with respect to y. Notice that those orders are different in the notation, the way we write them, but they mean the same thing. So first differentiate with respect to x, then differentiate with respect to y. And lastly, we're going to differentiate both times with respect to y. So that is del squared f del y squared, which means take the derivative with respect to y of the first partial with respect to y. F sub y, which is f sub y differentiated with respect to y. So you differentiate with respect to y both times. Remark. F sub xy and f sub yx are called mixed partials, as are any higher order partials that take the derivative with respect to different variables. In mixed partials, it's what I pointed out before, the order in which we write the variables here, f sub yx is del squared f del x del y, xy, yx. Means the same thing, you're differentiating with respect to y first, and then with respect to x, but where we write those in the two notations is opposite. Next remark, as with the first order partials, we will often write something in terms of z. So we might write del squared z del x squared, or z sub xx, or because x is the first variable, f sub 1. These are all alternate notations for both of these, del squared f del x squared and f sub xx. Last comment, and that is that the notation is completely analogous for higher order partials of functions. These are functions of two variables, x and y, of more variables. So whether we have x, y, and z as our input variables, or x1 through xn. Let's do one little example with notation, and then in the next video we will actually calculate some higher order partial derivatives. So example 3.3.3. We are asked here to give 3 different notations For the third order partial derivative obtained from w is g of x, y, z by differentiating first with respect to z, then with respect to x, then with respect to y. Since we're talking about a third order partial, we'll have del cubed, I'll choose to use w, del cubed w, and if I'm using the del notation, the derivative that goes first is written on the rightmost side of the denominator. So del z, del x, del y. That's the same thing as writing w sub z, x, y, opposite order. And I can write that as g sub z, x, y as well. There's three different notations for that same third order partial derivative of this function g. In the next video, we'll do example 3.3.4, where we will calculate some higher order partial derivatives.